Okay, let's start the talk. Hi everyone, my name is Thomas. I'm an engineering manager at ExpressVPN. So first of all, we are super happy to be able to sponsor this open source conference. And we have a series of talks this afternoon. I hope you guys enjoy all of them. So let's start with mine. So here's a question. When some company says, we protect your privacy, what does that mean? Usually it means trust us, we won't look. And that's a promise, and promise can be broken. It doesn't have to be malice. It could be policy change. It could be a security breach. It could be because of a legal subpoena. And it could also be an honest mistake. I'm sure a lot of you guys are developers here, and developers, sometimes Nginx is logging more than it should. Sometimes AWS is doing that. And ideally, we would want something that is better that prevents us from doing that in the first place. So this is what I want to show you today. We have two systems we built that we are physically unable to see your data. Not because we promised, but we engineered it to be impossible. And we call this privacy by inability. Is it moving? Okay. So we will look at two production systems, our dedicated IP VPN and ExpressAI, our private AI service. They are different products, but same architecture idea. Let's start with dedicated IP. So ExpressVPN, we have been a consumer VPN for more than 15 years. And in the past 2 years, we have a new offering called dedicated IP. So instead of giving you a shared IP range that everyone can access, we give you one IP that is hosted by us, but only you can access. But then it creates a problem if you want to maintain one IP per customer. So if you are a backend engineer database in a traditional sense, you would design it like this. You would put customer ID next to the dedicated IP that we assign to you. While it works, it's not good for privacy. So we have to do something different. Instead of us, the server side, maintaining the source of truth, when we inventing the whole model, everything should be stored on the client side, so we can't get to it. And client side would prove ownership. Ideally, we would be able to separate the knowledge between our systems, so no system knows everything. So ideally, we would have our subscription service that knows that you are subscribed, but doesn't know which IP you are subscribed, you've been assigned. The dedicated IP service that knows you're subscribed but doesn't know which subscription you are, so they can't link your payment method back to you. And our VPN server that only knows that you have been authorized by our backend system. Ideally, we would do something like that. So I would show you step by step how we do that. So let's start with how we can connect to the VPN server. And in order to for the VPN server to recognize who you are without giving away your identity, we use JSON Web Token, or JWT. So as you can see, the payload in green is being encoded and signed by our backend system. So if we just put an IP address here and then have some of our backend system claim that you have access to it, the VPN server lets you through without needing to know who you are. And we call it the dedicated IP access token, or DAT. But then for our backend server to sign such a token, we would need to prove that you own the dedicated IP. And we'll also have to expire it, because sometimes you can terminate your subscription. So we need to expire it and renew it from time to time. And to renew it, to generate such a token, from the business perspective, we need to know if your subscription is active and if you have owned it before. So that is the refresh token that would prove that you have owned it before. But these two connects your payment to your dedicated IP. And if you send both of them to us, we would end up having the same problem. We would be able to connect your payment and the IP that is assigned to you. Well, we could tell you that we're simply not logging your request and then call it a day, but that's not good enough for us. If only we can have something that tells you the code that is running on our servers is exactly what we are showing you, open source, that would be great. And we have just the thing. Introducing AWS Nitro Enclave is a special VM that's inside of AWS EC2. And the EC2 can generate an attestation proof that shows what image is running on the VM. So if we give you some open source code that generates to the same hash that the attestation proof is showing and signed by AWS, then you know, well, the code is really running what we claim we are running. And the attestation, if you can see here, it actually includes a public key. That means and this public key is actually generated from when the enclave, the VM, is booting. So anything outside of the enclave, they cannot know the private key, and therefore they cannot decrypt any of the stuff that is being transferred to the enclave. And we use the key to encrypt any payload that we send to it to make sure it cannot be seen by anyone. Couple of facts about Enclave. It doesn't have permanent storage. It doesn't have internet access. It can only communicate with the host via a VSOC. And we use this mechanism and put it, we encrypt it and process the information. So the client would receive the attestation document from the service. Well, if it knows that the attestation document is good, then, well, it would continue on. But otherwise, it would terminate the operation. So with the attestation document, we have the public key. We use that to encrypt the subscription and refresh token. And then we have the dedicated IP access token. So this is how it all fits into the picture. But I keep mentioning the term refresh token. Where does the first one come from then? The answer is when you purchase it, which poses an interesting problem. When you buy something, you're most exposed to being connected to the things that you buy. If that's the case, you lose all the privacy that we just set up. But fortunately, we have a way to disconnect that. And the method is very similar to supermarket coupon. The reality is, it's like when you, instead of buying something with cash or credit card at a supermarket, you buy a coupon first and then use the coupon. That way, the cashier don't know your payment method and therefore cannot connect who you are with the things that you purchase. But the reality is a bit more complicated than that. So you see, coupons, they usually comes with a serial number, right? The serial number probably is connected to your payment method. So if that's the case, well, we would lose the privacy all over again. So we have to do something special. Introducing blind token. So instead of just buying a supermarket coupon, when you buy the coupon, the cashier can see the serial number of that coupon. We put it in an envelope and put a piece of carbon paper on it and have the cashier sign on it. So that way, the signature can transfer to the token without, to the coupon without the coupon is actually being seen. And this mechanism, we can represent that mathematically, and it's called blind token, and that's the mechanism we use. So there are some clever math behind this. I'm not going to dive deep into this, but as you can see, the process is about the same as I just mentioned. We blind it, we signed it, and then we unblind it. That means we put it in an envelope, sign it, and then take it out from the envelope. And because of the math, the signature is, it checks out. Okay, so here is how the purchase flow looks like bit simplified. So first you get the anonymous token, that is the supermarket coupon in my analogy, and then you redeem that token for an IP inside of the enclave. And then, well, in the end, you get an access token and a refresh token, which is everything you need to keep everything separate. So the whole flow actually looks a bit more complicated, but if you're interested, here's a QR code that you can scan to learn more. I would be showing all of the QR codes throughout at the end of the presentation, so no need to worry. So in the end, we have successfully created a system that knows nothing. As I mentioned, the subscription service doesn't know your IP address, the dedicated service doesn't know your subscription ID, and the VPN server doesn't even know who you are. And the system is a little bit complicated, but I hope you recognize the privacy benefits that comes with it. So let's switch gears to our production system number 2, ExpressAI. So normally you send a request to AI providers. The encryption ends at the load balancer or the instance itself, which means the operator can see all of your requests. I mean, of course, the AI companies would tell you they're not using your data, they're not seeing anything that the questions that you send. But then, as I mentioned before, privacy policy is just a policy. Imagine there are some requests that you want to send to a local model, but I mean, it happens. I'm sure that happens at times. But this service gives you exactly the same guarantees as a local model, but they give you bigger ones. So instead of sending it to a 4 billion or a parameter model, we can, ExpressAI has GPT-OS is 120 billion. So you get the benefits of a big model without compromising any of your privacy. And ExpressAI is using the same enclave technology that I talked about, which is encrypting everything end-to-end all the way to the GPU. Wait, what? How can one encrypt everything all the way to the GPU? How is that possible? And it turns out only 3 components are needed. They are the AMD SEV, QEMU, and NVIDIA confidential computing. AMD SEV provides us with a trusted execution environment. That means we can run applications with CPU registers encrypt and also memory encrypt. But that would mean you have to rewrite your application. And we don't really want to do that, and it ties us to a specific platform. And here's how when QEMU comes in. So if we rewrite an application and that application is QEMU, then everything runs on top of it, the VM and everything would gain the same advantages. They will be encrypted, everything will be encrypted. That way we don't have to rewrite it by ourselves, which we like. And with these 2, we can already create a very secure enclave. And we have the AMD SEV to thank for. It's doing all of the heavy lifting, boot attestation, hardware attestation, host OS measurements, guest OS measurements, and everything. The trust chain goes all the way down. Only then will AMD sign an attestation document, well, similar to the one that's signed by AWS, but now it's signed by AMD instead. This attestation will say, well, we are running what we think we are running, and the good news is you can attest to it too. Now we can add a normal GPU and call it a day, but the moment the information cross over the PCIe boundary, the data would be decrypted because it's not encrypted in any way. If that's the case, that defeats the whole purpose of using an enclave, and we don't really want that. So here's when NVIDIA confidential computing comes in. When you pass through a GPU with the feature confidential computing, it puts it in a special mode that, well, disconnects the GPU from the host. And it would, well, it will show in the inside of the virtual machine as if it is a normal GPU. But because it has hardware support, it can do all of the encryption, everything that is available on the GPU and the memory itself. So we have an end-to-end encryption everywhere. And the whole flow looks like this. Your laptop is here, and then you have AMD up top. It fetches a key from AMD just so we can attest to what the attestation document is saying. The CPU was, AMD would sign the chip, and the chip would sign the image that we are running on it and generate a attestation report. And that includes everything, and especially the public key, private key pair that we use to encrypt our AI queries. So if we use that key to send payload, it would be end-to-end encrypted. And this is what you will see when you visit our app.expressai.com. On the right-hand corner, you would be able to see an attestation report that says, well, everything's verified, along with a cryptographic binding, which is the key that we use to encrypt our payloads. So far we have covered a lot of tools and methods and mechanisms that we use to provide privacy by inability, but it's not without their limitations. First of all, as we have noticed already, the system design is kind of complicated. That means more development time, more troubleshooting, but troubleshooting is also difficult because when we design a system, we don't want ourselves to be able to ever access to it. So we have very strict measurements on the image and the OS. So if we want to enable debug, but then the fact that we are enabling the debug changes the measurements and cause the attestation to fail. So clients will stop sending requests to it, and we can't debug it live. So we can only debug it local, which limits or has a lot of limitations. But this is something we want to live with. This is what we want to provide to customers, so we're okay with it. We are also opening ourselves up to refund abuse because we don't hold the source of truth anymore. Remember, the source of truth is now on the clients. But because of this mechanism, it can take some time before we can release an IP back to the IP pool if we found someone is abusing our service. It also doesn't solve everything. We are still suspect to timing attack. That is the time between you buy a subscription and the moment between when your subscription is redeemed and the IP is marked as used. But fortunately, if we have enough customers sending us requests, then the timing is a little bit hard to correlate, but it's possible. So today we have covered two mechanisms, blind token and enclaves. Enclaves, we have AWS Nitro Enclave and AMD SEV. We love it so much that we keep using it in some of the systems, some of the projects we are developing. And we are open sourcing the enclave so you can do, you can see how we did it. And most importantly, attest to our claims, verify our claims. So trust, but also verify. Unfortunately, we're working very hard to get it open source, but it takes some time. We have to make sure everything is working. We're not saying or doing anything stupid, but then very soon, I hope very soon, you will be able to see what we are doing. So thank you, and stay tuned to our GitHub so you don't miss when we open source anything. There's the dedicated IP white paper that you can also see, and we are also hiring. So thank you very much. If you have any questions. Okay, no questions, that's good. Well, in that case, thank you very much.